Can you guys hear me? So I'm going to be talking about building scalable gRPC service with Kubernetes. So I'm going to be talking kind of in two parts about gRPC and also about Kubernetes and how those can kind of work together. So just to give a little bit of an intro to myself, I'm a developer advocate on the Google Cloud Platform team at Google. So I do a lot of things like talk to developers and go to conferences and give talks and basically make it so that it's really easier for developers to use Google Cloud Platform and related services. So I'm also as I was introduced, I'm a kind of long-time Python user and Python community member in APAC, and I'm involved in the PyCon JP in Japan, and have done a lot of work in the Python community. So I'm really happy to be here in Taiwan at PyCon APAC for the first time. So I also like coffee, so this is me and a couple other Googlers in San Francisco having some coffee. So that's where I got the original image here. So I thought that was kind of good because we were kind of having a nice coffee together. So here's the agenda for what I want to talk about today. So I'm going to be talking a little bit about gRPC and the concepts and what gRPC is, and then talk about gRPC and Python. gRPC supports a number of languages, but I'm going to be talking specifically about Python. Then I'm going to start talking about, in the second half, talk about Kubernetes and containers and the concepts around those. And then talk about how to actually run the gRPC service in Kubernetes. And then just kind of wrap up and talk about, reiterate what we've talked about so far. So just getting into the gRPC concepts. So what is gRPC and what is it, what is it good for and why is it, why you should use it? So I think a lot of people are kind of familiar with REST services, like things like gets and puts over HTTP and stuff like that. And this is actually something that's more kind of going back to the RPC kind of roots. And so I'm going to talk about like why we are actually going back to, or not going back, but talking about RPC rather than something like REST. So here's a little. I'm going to be talking about gRPC just in a nutshell here, but here's so gRPC is basically a remote procedure call, so it basically makes it so that you can call a function on your local server or your local machine, and then that will actually make a network call to a server and get the data that you need and return the data, return some data that you can use in your local application. So that your local application, from your local application, it's as easy as just making a method call, and you don't really have to think too much about actually opening the sockets and managing that sort of stuff, the network communication. So that's the same basically from other RPC frameworks. But what makes gRPC different is that it supports HTTP2, which is the newest HTTP protocol that's come out recently. And I'll be talking a little bit more about HTTP2 after this, but so on top of HTTP2, gRPC uses what is called protocol buffers, and we've released several versions of protocol buffers before, and gRPC makes use of the latest version 3 of that. But so we use protocol buffers as the actual data over the wire. So to kind of just talk about HTTP2 and why we decided to use it, HTTP2 is the newer version of HTTP, or the next version of HTTP. I think everybody's familiar with HTTP 1.0 or the 1.x versions of HTTP. So HTTP, the original versions of HTTP were all text-based, and were kind of inflexible in the sense that you had to deal with things like encoding the bytes and stuff, because in the protocol itself, you had things like new lines and spaces and things like that. And so actually including data that had new lines and spaces was something that was a little bit tricky, and like there's a lot of like kind of nuanced things about HTTP that are problems. Also HTTP, like you would send the headers and along with your HTTP requests for every single request, and so that can get pretty big, especially with modern applications where you could have like a really big cookie or a really big group of headers that you have to send in every single request. Also, HTTP would make a new connection for every single time that it had to make a request, and so there are some kind of workarounds on like keep alive and things like that for HTTP, but it wasn't really geared towards reusing things like connections, and so creating new connections all the time, and that's pretty inefficient. And so so HTTP had its kind of limits to what it could do, and so it didn't seem like it was a very good way to or a protocol to build gRPC on top of it. So HTTP2 kind of solves a lot of those problems because HTTP2 is binary. It's not text-based. So no, you can't really use telnet, but you probably shouldn't be using that anyway. But I mean, even with HTTP, where it was text-based, you still had most of the data was either encoded in binary or base64 or something like that. So you couldn't read it anyway. So that really doesn't change a whole lot. But HTTP2 is binary, so that makes it much easier to do things like compress it and make it so that it runs so that you don't have to transmit less bytes over the wire. Also, it's fully multiplexed, so that means that you can use fewer connections or just a single connection to do many requests. So you can, on one connection, you can send like a request, and then get response, instead of the normal way that you did in HTTP1, where you had to get a request and then wait for the response and then do the next request and then wait for the response if you were using the same connection. So what most of the browsers did and most of the clients did in HTTP version 1.x is they would create a bunch of connections and do everything in parallel, which was kind of expensive and for server and client resources. HTTP2 also has header compression, so headers don't need to be sent every single request, and they also can be compressed so that you don't have to send quite as many bytes over the wire. Also, the server can send things like push responses, so it can push data that it knows that the client needs. So if you do like a request for an HTTP page or an HTML page, the contents in the page, like the JavaScript resources or the CSS or things like that, can actually be pushed to the client because the client knows that, or the server knows that the client is going to need those. So that makes some things like really, really efficient. That's not used so much in gRPC, but it's used really, really quite a lot in browsers. So next I'm going to talk about protocol buffers. So protocol buffers is a way of serializing data. So things like say I want to have a person data or something, I can define what's in that and then actually create some code to actually serialize that. And so protocol buffers are just a way of taking some data that you have in your particular language and serializing that to binary, and then in whatever language that you're sending it to, deserialize it into the objects native to that language. So these are also in binary, so they can be parsed and serialized and deserialized very quickly. They're also very flexible, so like when you add new fields, your server and client don't necessarily have to know things like which version you're running on and things like that. The server and client can kind of ignore the fields that it doesn't know about and kind of make it more flexible when you're with different types of versions of servers and clients. Also, protocol buffers supports code generation, so you basically define which types of what type of data that you're going to be serializing and deserializing, and then then protocol buffers will actually generate code for you to actually do the serializing and deserializing, and also setting of the different fields within the objects. So let's look at what protocol buffers looks like. Protocol buffers is you create like a proto file to define the type of data that you're going to serialize. So here I've got a person record, and this person is going to have a name and an ID and an email, and then this data can then we can use this protocol buffers file to actually generate some code. So like in Python, you would generate a person class that would have a name and an ID and an email field that you could set, and then have some methods that would allow you to serialize that into the binary that you can use to send that to a server or to some other place. In protocol buffers, you can also define services. So like for RPC, like in gRPC, you can define a service that says like, that defines a method that you can use to call like a RPC service. So here I'm defining a getMe service that returns a person. So like say you're logged into this particular service, you can just say get me my person data, and that will actually return a person object. So when you run the protocol buffers compilers and the plugins for Python, it can actually generate code to connect to a RPC server and call this getMe method on the server and get you the person data. So next I'm going to talk a little bit about gRPC and Python, so just Python specifically. So first, in order to actually use gRPC in Python, you have to download the gRPC libraries. So from GitHub, you can just clone that down, and this repository actually contains all of the different libraries for all of the different supported languages. So things like Java and C++ and iOS, Objective-C. So those are like so this is the actual library, and so once you get that down, you can go into the Python directory and then actually build the gRPC library. And so what we're doing here is like just building the library using make and building the gRPC Python plugin. So gRPC has a Python plugin that gets used when you compile the protocol buffers to actually generate the Python code that you need to run your Python service. And then what you do is you actually run the protocol buffer compiler, which will compile the protocol buffer, and then run the plugin to generate the code that you need. So I'm going to show you a little bit about what that's like. So here is actually, let me just copy this, because I'm going to run that in a second. But I have a little project here. This is actually, let me just list here. So I have a little project here that has is a Hello World application. And what this has is it has a server-side component, a greeter server, and it has a client here somewhere. So here it is, the greeter client. So this is the client-side part of the Hello World application. And so each of these are code that that you would write to use to define your service, and then there's a section, a set of code that would actually be generated for the service itself. So if we go back here and look at, so here's like the actual protocol buffer for this particular Hello World service. So here we have a service that we've defined and a say hello method, and you pass that a hello request and it returns a hello response. And the hello request is defined here. You actually just give yourself your name in the hello request, and in the reply it gives you a message, and you can use that to print it out. So here we're just defining like the protocol that we're going to use to talk to the server, and then in our greeter server, so here's the Python code. So here in our greeter server, actually, we're going to have our say hello method that we define. So we've defined that we're going to have a say hello method. So we actually have to have the code that runs. That's hello world. And so here we're going to get a request and a context object. And in the request, it's going to have our name object, or our name field that we defined in the protocol buffer. And then we're going to reply with this hello reply that got generated from the protocol buffers, from the generation routine. And so we're going to pass the message that says hello and just uses the name that we were passed. And then this is actually just some code that actually starts up the server. So here we can create we create the server object and then just call start. And this is all code that's generated for you from your protocol buffers by the gRPC framework. Okay, so let me actually clear this and look at this again. So here we have that's the server side, and then we have the client. The client side actually looks pretty similar. So in the client side, we have just a run method, which is going to take create a stub that we're going to use to connect to the server. So this is like a client or a connection object. So here we use the generated a generated method that calls create greeter stub, which will create a connection to the service. And then we can call the say hello method that we defined with a hello request object and just give it the name. So here I'm just giving it my name, and then once we get a response, we can just print the response.message that we got back. So if we actually, but that's great and all, but we don't actually, so here I actually have the code generated already, but normally you wouldn't have this, so you have to actually generate the code. So here we would actually run the proto-C compiler to compile the protocol buffers. So here we have the proto file that I just showed you with the definition of the objects in the service, and I'm passing in this plugin which is the Python plugin, which will actually generate the Python code. So if I run this, it would actually generate the code here. So if I just go ahead and like delete this, so now it's gone, and then I run that proto-C again, it should actually generate the, let's see. Yeah, so here we have the Python code that it generated. And then I can look at that code and see what it looks like. It's kind of ugly code because it's actually generated code, but you can kind of look at the code, it's regular Python code, and see what it's actually doing. And this actually makes calls into the gRPC framework and does all the HTTP2 stuff and all that, for you. So you don't really have to worry about it too much. So if I just run this locally, let's see if I can run it. Server, is it just that easy? Yeah. So here I've just started up the server. And then what I'm going to do is go back into that, GitHub, gRPC, common, this is a little bit slow. And then if I just run the client, I think actually this is host. Yeah, so you can, this is actually printing out a lot of log stuff, but you can actually see that I connected to the server and I got a response back. So I passed it, the server, my name, and I got back a message saying, hello Ian, that the server created for me. So that's a really simple way of developing a service. So like but you can get as complicated as you need to, and gRPC like supports other things like more complicated setups like streaming data from a server to a client and that sort of thing. So but I'm not going to quite get into that in this presentation because I don't really have enough time. But you can definitely do quite a lot of stuff with gRPC. So with that, I'm going to kind of go back to the presentation. And so that's all well and good. You're running that locally, and that's cool and all. But you want to create a service that people can access on the internet and can actually make use of. So that's where like things like Kubernetes and these kind of other frameworks for deploying services come in. So just to talk about like current practice, like normally you would have something like this, like a bunch of web servers and connecting to a database and a cache and stuff like that. But these are kind of like shared machines, or VMs or something like that. So like something like a shared machine where you have your apps all running on the same machine and the libraries and the kernel, like all of those things are tightly coupled together. They depend on each other really heavily. So if you change around the libraries or the kernel, then your application could break or have problems. And also the applications, some applications use memory or CPU like quite different than other ones. And so if one application is using up too much memory, that can like cause problems with other apps in the performance of those apps. And virtual machines kind of helps isolate that to some degree, but so you can isolate things like performance and memory and stuff like that, but you can't really, but you have to run an entire VM, so you have to manage the OS and everything on up. So you're still tightly coupled between the application and the OS. So these are also kind of hard to manage because you have to like, maintain all of the versions of the different kernels and or the different OSs and things like that. So containers are kind of like a happy medium, between something like a full VM and a platform as a service. So platform as a service, like you don't have to manage any of the stuff like the OS and the servers themselves, but they're very limited in like what types of software you can run. You can't run like just any software. You can only run the software that's supported by that particular platform. And VMs are great, but like they have all the downsides that I talked about. But actually running containers, you can run any type of software you want, you can run any libraries you want, any type of binaries you want, but you still have the kind of flexibility or the decoupling between the OS and the application. So you can kind of vary those a little bit more. And so that allows you to get a pretty good balance between agility and flexibility. So containers look something like this, where they run actually on a shared kernel but are packaged with the libraries that they need. And they can also be isolated in terms of performance. So things like you can only assign a certain amount of memory to a particular container, and that won't affect another container. So each of those applications will have enough memory to actually run, enough memory and resources, CPU and otherwise, to actually run. And just a background, like, everything at Google runs in containers. So Gmail, web search, apps, everything. We actually launch over 2 billion containers every week. We run all of our batch processes, even our VMs in Cloud Platform run inside containers. So they run as processes within containers. So for all of the reasons that I mentioned, like things like performance, repeatability, resource isolation, quality of service, accounting for all of those processes and managing them, containers are a really great way of managing processes on a lot of machines. But that's great and all, like Google uses all that stuff internally, but that's like kind of internal to Google. So we decided that we wanted to make that sort of technology available to people outside of Google, because containers were becoming very popular, and there are good ways of running containers now, like Docker and CoreOS, Rocket, those type of things. So we wanted to create something that people could use to deploy applications using containers. And so we created something called Kubernetes, which is an open source project to manage a cluster of containers. And so Kubernetes is written in Go, and it's a very efficient way of managing these containers, and it provides an API for you to start containers and stop them, and define services and type of policies for managing groups of containers. It's a open source project, and we have a lot of partners. So things like CoreOS, HP, IBM, all these type of companies have people working on Kubernetes and are developing services around Kubernetes. And so we think this is a really vibrant community, and it's very popular. We have over 369 contributors now, and over 8,000 GitHub stars. So it's getting quite popular, and we think that this popularity will actually grow in the future. So just a couple concepts, like Kubernetes has the concept of a pod, so you can run a pod, which is a group of containers inside of a host. So that makes it so that you can give an IP to the particular pod, and then the containers within the pod can talk to each other on localhost. So containers that work well together or work closely, like logging servers or things like that, like FluentD or Logstash or those type of things, can be bundled with your applications. We also support labels, so you can label your pods and use that to define services and other things. In the future, you'll be able to do things like create dashboards and view which what type of resources and performance you're getting out of particular containers within your cluster. There's also the idea of replication controllers. So these are things that actually manage the pods. So these tell your cluster that I want to run this number of pods, and I want to keep them running all the time. So if those pods, the containers within the pods die, it'll restart them for you, and stuff like that. You can also resize these and do rolling updates. You can do all kinds of cool things. So I'll talk a little bit about that later. You can also define services. So services are a way of defining an IP address, and then having that, allowing you to connect to that IP address and actually load balance across a bunch of different pods. And so I'm actually going to use this to define my gRPC service. So what I'll actually have is I'll have a service with an IP address that I can connect to, and that will actually load balance across a bunch of other gRPC pod servers running within the cluster. So I'm going to go and do a little bit of a demo to talk about how you would actually run a service. So first, what you would do is you would create a Docker image for your service. So here's kind of a complicated image, because I wanted to use the latest version of gRPC, but there's actually a gRPC image that you can use and build off of. But here what I'm doing is I'm actually creating a Docker image using a Docker file that actually installs gRPC and does all of the things that I talked about, which is basically running make and building it. And then that will actually install gRPC locally, and then run the proto-C compiler here, and run the plugin and everything to generate the code, and then actually run my greeter server. So that'll actually generate my Docker image. So once I do that, I can upload that to a container registry, and then use that to deploy my application. And you use that, you'll use something like Docker build to actually build this, and then you can use the G-Cloud or the Google Cloud SDK to actually upload that to the Google Cloud registry. So I've kind of done all of that already, but so I'm going to kind of skip over that. But so once you've done something, once you've actually created the Docker image, you'll need to you'll actually have to create some configuration, and this is pretty much just boilerplate. So what I'm doing here is actually defining the replication controller that I'm going to use to deploy my application. And the interesting part is here, like you can say like that I have two, I'm going to create two pods that will be load balanced against for my service. I also give it some labels. These are the labels that I talked about, and I can use those to like version up the application later and to actually define which pods are going to be used by the service. And then here I'm giving it the image that I've uploaded to the container registry, and telling it which port I'm actually going to run on. So this actually allows me to connect to my pod on that port, and then once I do that, I can actually define a service. So here's a service YAML file, which will define the service and the port number. So here I'm defining a port number that I'm going to use for my service, and then this is target port is the port that's going to be used to connect to the actual container. So this port matches the port that was in the replication controller. And then I'm going to create a load balancer to actually be able to access that from externally. So now that I've done all that, I'm going to actually just run the Kubernetes control command, which will actually create my my resource controller in Kubernetes. And so once I do this, that will actually create the replication controller, and the replication controller will start my pods for me. And what that does is it'll download the Docker image and then run the image, or run the container in Docker. So what I can do now is I can run get pods, which will tell me the pods that are actually running. So here I can see that I'm running. These are actually pretty. This is actually pretty hard to read, but I can see that I'm running a few pods here. There's actually a couple running here. Let's see. So this is actually something else. But this is so here's my image, and that's telling me that that's running. And then here's my other image, or my other pod, and that's actually that's also running. So I'm running a couple of pods. And so now that I've created that, what I need to do is actually go and create my service. Front-end service. And so after I create the service, let's see, I can run get services, and that should show me my service somewhere in here. Yeah, so this is the actual service. So I've given it the name of gRPC Hello World, and that actually is going to load balance across all of my my pods and using this port. So there should be an external IP address that gets attached to it. So this, I think, is the external IP address. So once I do that, I can actually connect to my running cluster with that IP address. So here I'm actually going to run the client application that I created and give it the IP address of my running cluster. So hopefully this will work. Yeah, so now that I've given it this IP address, whoops. Now that I gave it this IP address, it actually was able to connect to my Kubernetes cluster and run the RPC across the cluster. And so what this will do is actually just load balance across the pods and give me a kind of way of creating lots of pods to handle the load on my particular service. So with that, I want to go back to the presentation and then kind of try to wrap up. So basically, that's like a really good way to create a service. And actually, if I have a minute or so, I can actually go here and show how to resize something like that. So like when you want to actually scale up your application and show and actually run more pods. So what you can do is you can PC hello world and then replicas and say like 4 or 5 instead. So what I can do here is I can actually resize the replication controller so that instead of running 2 pods, I can run 5 instead. And so that when your service is actually getting more traffic, you can actually scale that up pretty easily. So here, that'll actually just resize that. And then what I can do is get pods and grep gRPC hello world. This is actually really hard to read at this size. Maybe I can make this a little bit smaller. So I should be able to see about 5 pods running here. So here's one. And you can see that that's been running for about 24 seconds. Then we have another one that's running about 4 minutes. 2 that's running for about 4 minutes. And then we have another 2 that are about 30 seconds. So you can see that like when I resized it, it kept the original 2 pods, and then it started let's see, 2, 3 more pods. So what it did was it actually like looked at the current state, which was 2 pods running, and figured out that it needed to start 3 new pods. And so that's actually the way that you can actually scale up your application. So thanks a lot. And if there's any questions, I can answer those maybe in the last couple minutes that I have here.
Any question?
One right there, I guess.
I have a question. And you using the HTTP 2.0 and the gRPC using the protocol buffer. And one thing we compared with before, we using the plain text to transfer our messages. And now we use a new protocol and how to debug and troubleshooting. Could you have any good suggestion? Thank you.
Okay, so there's a couple ways that you can kind of debug. There's like, there are like things, like if you want to actually debug by looking at the protocol, there are like some plugins for things like Wireshark and stuff like that that will actually allow you to look at the internals of the HTTP2 requests. So there are kind of tools around HTTP2, but it is like a little bit harder to read compared to HTTP. But we can expect that there'll be more tools for like debugging the actual protocol itself in the future. Right now there's not too many, but like you can use things like Wireshark and the plugins available for that like right now. Hopefully that answers your question, and if not, then you can kind of come by the booth, the Google Cloud Platform booth, and we can talk a little bit more about that. Are there any other questions?
Okay, please.
Yeah.
Oh.
Hi.
Do you recommend to use gRPC on production service? Because I found the gRPC GitHub, the libraries are all alpha stage.
Right. So right now we don't really recommend that you use it for production necessarily. It is like something that's kind of developing right now, so it's kind of a new service. Also, Kubernetes is a pretty new service also. So I mean, these are kind of somewhat new services that will become that we think will become more popular in the future, but like not necessarily ready for production right now.
Okay, thank you.
Yeah.
Okay. Let's again thanks Ian, please. Thank you.
All right.